Hello, I'm Janvi from Team 24, and our cloud computing project is a cloud-based clinical decision support system. So, what exactly is a cloud-based clinical decision support system? It is basically an expert system that we're hosting on cloud. Uh, it is a system which makes predictions, which makes diagnosis based on the symptoms that are expressed by the patient. So, when the patient fills out the details, uh, we use highly trained machine learning models to make the predictions. So we've made a web application that we are going to host on AWS Cloud. So we made it on VS Cloud. This is basically the home page. It has the buttons to navigate through all these web pages, the home page, the patient care page, staff account page, about page, and contact page. So basically we've listed our objectives here. The system will directly give initial level advice to the patients on analyzing their consultation and medical records, live tracking of the parameters. Alert is sent when abnormalities arise, prediction of future complications, and in case of an emergency, a precise treatment process ensured, even in the absence of healthcare providers. And this is the About page where we've written about our application. It is an expert system that produces diagnosis by processing patients' input data and using machine learning models to generate the predictions about us and our goal in making this application. It is a self-sufficient software that can analyze all kinds of patient information and generate advice in patient diagnosis, faster delivery of healthcare services and decision making, monitoring of each individual patient's data and data as a whole, predicting future anomalies which can help in prevention of certain conditions. So let us host it. Let us first run it. Yeah, so this is the home page. This is the patient care page where we enter our details so that based on this, the system can make the predictions, the diagnosis, staff account page, specialist page, and the about us page. So yeah, now let us deploy it on cloud. We are using AWS Amplify. To deploy our application. AWS Amplify is basically a hosting service through which we can directly host our app without any Git. So we can directly upload our files to host our application to deploy our web application. Now, let us create a new app, host web app, deploy without Git provider. And let us give the app name cloud-based CDSS. Choose files. This is it. And save and deploy. So the app is being created. It is being deployed manually. Yeah, so deployment successfully completed. We can update the app through this option, and this is the domain through which we can access our website. So let us enter our details and submit form. So basically what happens is We are storing the data that the user is entering in S3 and Amazon Health Lake. In S3, we have a CDSS data S3 bucket in which we have the training and the testing data for our SageMaker to make predictions based on. And this is the My AWS bucket Health Lake one. So basically, we are storing the data that the user is entering in a data store in Health Lake. I've already created a data store. So this is the data store that I've created. And we can, in this, the data is stored, the data that the user enters. And we can run queries on it. Any type of query. Let me enter resource ID 19 and run the query. So because as the user data can be queried on, can be made sense, we stored it in Amazon Health Lake. We've basically imported the data that we've stored in S3, the user input data that we've stored in S3 in Amazon Health Lake. So in S3, my AWS Health Lake 1. This is what we've imported in Amazon Health Lake to make queries on. So basically the user input data. And this is the CDSS data S3 bucket, which has the training and the testing data for SageMaker to make predictions. So let's go to SageMaker. So in SageMaker, we can build machine learning model, train and deploy machine learning models at scale. So I've already, this is the notebook that I've already created. So this is the notebook. So this is basically the notebook. So in this, I've written the code for the machine learning model, which is trained on the data that we've stored in S3. This is connected to S3. We've stored the training data in S3. The training data is like this. So basically, we have a whole bunch of symptoms: itching, skin rash, and when a symptom is present, we write it as 1, and otherwise it's 0. And for a combination of symptoms, the prognosis, that is the diagnosis is made, either fungal infection or allergy. Training data is basically the real-time data that is collected over a period of time where a real diagnosis is made by doctors. So for a patient one with these symptoms, the doctor has made a diagnosis fungal infection. And for the same symptoms, there may be a different diagnosis. So the model trains on all this data so that it can make good predictions on real life data. So let's go to, yeah. So I've imported all the libraries that are necessary, Boto3, JSON OS, SageMaker. SageMaker we have imported so that we can directly fine tune the algorithms that are the models that are already provided in SageMaker. And we've created the CDSS data S3 bucket that I've shown previously through SageMaker. And then I went to S3 and uploaded the training and testing data there. And now, so this is basically showing because I've run this notebook again and it says that I've already owned this bucket. Pip install AWS Wrangler. So I'm basically installing AWS Wrangler package. And I'm storing the training.csv, which is present in the CDSS data S3 bucket in S3 in a data frame, and testing.csv in another data frame. So df.shape gives the dimensions of the first data frame. So the training data set has 4,920 rows and 133 columns. So basically 4,920 different diagnoses based on 133 symptoms. And testing data has 41 rows and 133 columns. And I've stored the paths of both training and testing in two variables, S3 underscore input underscore train and S3 underscore input underscore test. So df of prognosis dot value underscore counts normalize equal to true. So we are basically normalizing the value that is associated with each diagnosis so that the values lie between 0 and 1. And we are visualizing the data this data using graphs. And now we are importing matplotlib, seaborn, all these two basically for visualization so that we can make better sense of the data. Here we are analyzing each symptom / variable. So we are basically visualizing each variable, each feature. And this code is for checking the relationship between the variables by applying the correlation. So we are basically checking how strongly the features are related or how weakly the features are related so that it will be helpful in pre-processing. So if the features are strongly related, we can make prediction based on that the other feature, or when they are weakly related, we can basically delete any unwanted columns. So in that way, and we are importing the chi-square contingency. So basically to test the hypothesis. And now we are importing sklearn so that we split the data into training and testing. We are using a 66%, 33% split. So 66% training data and 33% testing data, 67% training data. And we are using multinomial naive-Bayes classifier for the model. So we are going to apply this model on our training data so that the model can learn and make the predictions. Now we are fitting this model onto our training data, and we have stored our predictions in ypred, y_pred, and the accuracy we've gotten as we've got 100% for training data, but we need to cross-validate it so that we know that it's not only for this sample, this accuracy we will get for all different samples. So the test values, the test prediction values we've stored in a variable called real diseases. Even after cross-validation, we've got the accuracy as 100%, which means that no matter what the samples are, we are, so there is no fault in our model, basically. Even on different samples, when we apply this model, we'll get similar results. So all the test prediction values we've stored in real underscore diseases and we are printing it. So basically we have 41 rows in our test data. So 41 different diagnoses, 41 different test predictions are made and they're printed in this manner. So, yeah. And now, after the test predictions are made, we've imported K-fold to perform K-fold cross-validation. This is a function to run multiple algorithms with different values of K-fold. So by testing with different K values and different algorithms, we will know with which model and with which value of K we'll get the best testing accuracy. And these are all the different classifiers that we can use. So we have found that the decision tree is best fit. We've got a training score of 100% and a testing score of 87% with a K value of 2 in the K-fold cross validation. So yeah, we've basically plotted the train scores and the test scores. And now, as we've got the best testing accuracy at a K value of 2, we are building a decision tree model with a K value of 2. And we are printing a training scores and a testing scores. So basically, we use K-fold cross-validation to, as we've got a training accuracy of 100, we are validating that accuracy so that we get the best testing accuracy. So the best accuracy for new data. So now as we've got a test accuracy of 87%, it means that our model can make highly accurate predictions on real-time data. So this is the code to make the predictions, to make the real-time predictions. So basically I've entered the name and age. And for each symptom, we have a number associated with it. And I've entered the symptom number as 2. And my model has predicted that has made the diagnosis, has predicted that the infection is chronic cholestasis with a confidence score of 100%. Yeah, so as the data that we've entered is stored in S3, and we access S3 through SageMaker. We access the training and testing data that is present in S3, and we make the predictions based on it. Here our prediction is chronic cholestasis. So these are all the services that we are using SageMaker to make the actual predictions that can be used by the hospitals to make the real diagnosis. S3 for storing all the storage, and Health Lake to make sense of our health data, and AWS Amplify to host our web application. Yeah. Thank you.